we are on our next lesson. Go ahead and turn to page 315. If you haven't done that, go ahead and pause the video and press play when you're there. Today's lesson, we are going to be comparing fractions again, but it is going to get a little bit more complicated. So make sure that you take notes, make sure that you're following along with me, and also do remember that this is a video and you can always play it over and over again if something's not making sense to you, okay? That's the great thing about a video. All right, so this first part is not bad. We're going to be using number lines to compare the fractions. So here we have 4/5. We have our fifths line right here, and we have 7/10. So where would 4/5 be? Right here. And down here we have 7/10. So which fraction is greater or farther along, closer to 1? It would be 4/5. Not too bad. Okay, next one. Use the fraction strips to compare the fractions 3/4 and 4/6. So if we have 3/4, 1, 2, 3, we'd be over here. We would just fill in 3 of these 4. And 4/6, we would fill in 1, 2, 3, 4. So it'd be right here. 4/6 would be here, 3/4 would be here. So which fraction is greater? 3/4. All right, now we are going to be comparing these fractions using the number line and the fraction strips up here. So if we have 3/4 and 7/12, we've got 3/4 here versus 1, 2, 3, 4, 5, 6, 7 12. 7/12 is right here, 3/4 right here. So 3/4 would be larger. 3/5 or 7/12? Let's see. 3/5 or 7/12. We don't have fifths and 12ths here. So we can find over here 1, 2, 3, 4, 5, 6, 7/12 is right here. And up here we have 3/5. I think that we might even have to make another fraction strip up here. Fifths would be maybe a little bit bigger than fourths. 1, or no, I'm sorry, a little smaller than fourths. 1, let's get a different color pen. 1, 2, 3, 4, 5. Not perfect, but it works. So 1, 2, 3/5 would be about right here versus 7/12. So I think 3/5 is bigger. 3/5 or 6/10. We have 3/5 here or 6/10. Up here, 3/5 or 6/10. They are the same. 2/5 or 3/6. 2/5 or 3/6. 2/5 or 3/6. 3/6 would be, if we had sixths, we would say 1, 2, 3, 4, 5, 6 right here. So 2/5, 1, 2, 3, or 3/6. I would say 3/6 is bigger. Okay, 4/10 or 1/5. 1/5, this is an easier one. 1/5 or 4/10. 4/10 is bigger. Last one, 2/10 or 3/8. 2/10, 2/10 or 3/8. We don't have eighths on here, but I want you to imagine we have 2/10 over here, and 3/8 is just barely under 4/8, right? And 4/8 is 1/2. So it's barely smaller than a half, and 2/10 is a really, really small amount. So I'm just gonna say that one is bigger, okay? All right, this next page gets very tricky. Now we have all these different rules Let me go ahead and read the top part to make sense of it. You can compare two fractions with different denominators by writing or making equivalent fractions that use the same unit fraction. Okay, these fractions will have a common denominator. You can use different strategies to do this. So let me kind of explain this a bit more. So in this first case, we have 3/5 and 5/10. They both have different denominators. They have different numerators. How are we going to compare them? They're completely different fractions. So this is a way, there is a way that we can do it by making equivalent fractions. Now, if you look at these two denominators, 5 and 10, 5 is a factor of 10, or you could say 10 is a multiple of 5. So you could say, oh, okay, I can make these two denominators, I can change this one so that it can have a denominator of 10. And let me show you how to do that. It explains it here, but okay, our first rule is use the greater denominator. If both of the numbers work together, kind of like 5 and 10, they work together very nicely, you're going to use this greater denominator. Now let me explain that. You're going to say, okay, 3/5 times what would give me a 10 on the denominator? I'm going to change this fraction, 3/5, so that it has a 10 on the denominator so I can compare it to 5/10. So 3/5 times, well, 5 times what would give me 10? That would be 2. So my whole that I'm going to multiply it by is 2/2. So 3 times 2 is 6. So 3/5 is equivalent to 6/10. So now instead of saying 3/5, we can say, oh, let's compare 6/10 to 5/10. Look how much easier that is. Which one is bigger? It's a lot easier to say, oh, 6/10 is bigger than 5/10. Instead of going, oh, I don't know, 3/5 versus 5/10, they're both so different. So we're changing 3/5 so that it can cooperate. It can have the same denominator, so it's easier to compare, okay? So sometimes when you see these denominators, use the bigger one. If you can work with both of them, use the bigger one and say, okay, I'm gonna make this denominator a 10, okay? And you're going to use any fraction of 1 that'll help you get there. I'll give you another example of that actually, because I know this can get tricky. So let's do, let's say we have 2/8 versus 3/4, okay? So 4 and 8, they both work together, right? 4 is a factor of 8, and 8 is a multiple of 4. So we're going to use the greater the denominator right here. And this fraction, I'm going to change it so that it can have that greater denominator. So 3/4, I'm going to multiply it by a fraction of 1 to get me an 8 on the denominator, okay? So what is that one going to be? I'm going to take a look here and I'm going to say 4 times what gives me 8? 2. Again, wow, that's cool. So 2/2 is what I'm going to be multiplying. 3 times 2 is 6. So now I'm comparing 3/4, I'm saying is the same thing as 6/8. Okay, so now I can compare 6/8 to 2/8. And it's clear to me that 6/8 is way bigger than 2/8. All right? So that's rule number 1. Use the greater denominator. I'm going to show you rule number 2. Rule number 2, and it's listed over here. I'm just kind of putting it in my own words, but you're welcome to look on this page 316 anytime you want to help give you a refresher. So now we're going to go to case 2. All right? Sometimes you have denominators that are completely different, like 5/8 and 4/5. 5 isn't a factor of 8. 8 isn't a multiple of 5. They're totally different, right? So what you're going to do is you are going to change both of these fractions. You're going to change them so that first, let me go ahead and write it here. So we have 5/8 and 4/5. You're going to try to find a denominator that works for both of those numbers. And in this case, I'm going to multiply 8 times 5, and that equals 40, okay? So what you're going to do is you're going to make 5/8 over here. You're going to change 5/8 to equal, times something to equal something with a 40 in the denominator. You're going to do the same thing for 4/5. 4/5 times a fraction of 1 is going to give me something over 40. Okay, I know this gets really tricky, and you're welcome to watch this multiple times. Okay, so if I go and I say, okay, I'm going to change 5/8 to something over 40 so that I have two denominators that are the same. I can compare them when the denominators are the same. So 8 times what gives me 40? 5. So my 1 is going to look like 5/5. So 5 times 5 is 25. So 5/8 is the same, is equivalent as 25/40. Now we're going to do the same thing for 4/5. We're going to change this to make it equivalent with to something with a 40 in the denominator. So 5 times what gets me 40? 8. So I'm going to multiply 8/8. 5 times 8 is 40. 4 times 8 is 32. Okay, so now I can clearly see which one is greater, 25/40 or 32/40. It's clearly going to be 32/40. So 32/40 is equivalent to 4/5, right? So I can go back over here and say, yeah, 4/5 is greater, because 4/5 is the same thing as 32/40. 5/8 is the same thing as 25/40. And when I put it in these terms, where both of them have 40, it's easier to compare than just going off of this, okay? So that's strategy number 2. You multiply denominators and find equivalent fraction for both. Okay, so you multiply the denominators, and then you find the equivalent fractions for both, for that denominator. Okay, rule number 3, and that's over here. It's the one in purple. You're going to compare 5/8 and 7/12. Use a common denominator. Okay, so this one, you are trying to think of, see, sometimes like that second rule that we did, you would come up with really, really high numbers sometimes. Like we're going to have the numbers 5/8 and 7/12. If we were to multiply 8 times 12, that would give us 96. That's a really, really high denominator. Now, we could do that, but I'm going to show you a third trick, okay? It says to use a common denominator that is less than the product of the denominators. That's a little bit tricky to understand. Let's see. Okay, so in this it says 24 is a common multiple of 8 and 12. So think about, okay, 8, 16, 24. 24 is a multiple of 8. 24 is also a multiple of 12. So you can go through and you can say, oh, okay, 8 plus 8. You can find what's called the least common multiple. So if you were to add 8 plus 8 plus 8, I'll do that over here to the side. 8 plus 8, or no, 8, the multiples of 8 are 8, 16, 24, 32, right? And then 12, you have 12, 24, 36. You can tell that 24 is a common multiple that those two numbers have in common. So what we're going to do is we're going to change 5/8 so that it can have a 24 on the denominator. Same thing with 7/12. We're going to change it so it can have a 24 on the denominator. So 5/8 times something is going to give us 24 on the bottom. And 7/12 times a fraction of 1 is going to give us something with a 24 on the bottom. So let's think about this then. 8 times what gets me 24? I can see that over here. 8 times 1, 2, 3 gives me 24. So my whole number is going to be 3/3. 5/8 times 3/3. 5 times 3 is 15. So 5/8 is equivalent to 15 24ths. And 12 times what gets me 24? 12 times 2. So my 1 is going to be 2 halves. 7 times 2 is 14. Look at that. Look how close those two fractions were. So we have 15 24ths or 14 24ths. So it looks like 15 24ths is the bigger fraction. 15 was equivalent to 5/8. So 5/8 is the bigger fraction. I know this is a bit tricky. Please make sure to watch this video multiple times if you need to, and I'll see if I can find other videos that can explain these rules. But these three ways these three ways of comparing fractions are awesome. They all kind of need you need to be able to find equivalent fractions to do any of these. But they are very, very helpful. Okay, it's a lot easier than looking over and trying to figure out a fraction strip or a number line. In my opinion, it's a lot more efficient when you know these kinds of rules. All right, so we are going to figure out these numbers, number 9 through 14, by using these strategies right here. Okay, so I'm going to get a scratch piece of paper here, and this is what I want you to do anytime that you need more room, okay? And we are comparing 3/5 to 2/3. I'm going to write this over here on my paper. 3/5 and 2/3. So I cannot use rule number 1 because 3 is not a factor of 5. 5 is not a multiple of 3. 5, 10, and really, if you, I'm just gonna go ahead and use rule number 2 because 15 as a denominator isn't too high. So rule number 2, remember, was to multiply the denominators, find an equivalent fraction for both using that denominator, okay? So I'm gonna go 5 times 3 is 15. That's the denominator that we are going to change these fractions to. So I'm gonna make 3/5 times a whole to equal something with a 15 on the bottom. 2/3, I'm going to do the same thing. 2/3 times a whole to equal something with a 15 on the bottom. Okay. Now, 5 times what is going to get me 15? 3. So that's going to be 3/3. 3 times 5 is going to get me 15, so that's going to be 5/5. All right. 3 times 3 equals 9. 2 times 5 equals 10. Very close fractions. Which one is larger? 10/15, which is the same thing as 2/3. So I'm going to go over here and I'm going to say 2/3 is larger. Okay. Number 10. I'm going to go ahead and write that down on my scratch piece of paper. 10/12 and 5/6 over here. 10/12 and 5/6. Rule number 1, I think I can use. 6 is a factor of 12. 12 is a multiple of 6. So I'm going to keep this the way it is. I'm just going to change this one, 5/6, and I'm going to times it by a fraction of 1 to equal something with a 12 on the bottom. So 6 times 2, this is going to be 2 halves. 5 times 2 is 10. Oh my goodness. It looks like they are equal. 10/12 is the same thing as 5/6. So I'm going to go over here and say equal. Okay. 3/4 or 8/10? 3/4 or 8/10? I think I'm going to go ahead and do strategy number 2. I'm going to multiply these two. And I'm going to make that 40. Okay. So now I'm going to do 3/4 times something equals something over 40. And I'm going to do 8/10 times a whole equals something over 40. So that I compare both of them. I can compare both of them if they both have a 40 on the denominator. So 4 times 10 equals 40. So this is going to be 10/10. 10 times 4. So this is going to be 4/4. This is going to be 30/40 versus 32/40. Very close. So it looks like 32/40 is bigger. So that means that 8/10 is larger. All right. I'm going to go ahead and do, let's see, I want to do one more with case number 3 in it. Although I don't see one with case number 3. So I think number 12 would probably be case number 1. You can make both the denominators 100. This one's already 100. This one, I would say use case number 2 for that, okay? And for this one, I would say use case number 2 for that one as well, where you're gonna multiply just the denominators to figure out what the same common denominator will be. All right, so you're going to go ahead and do that, and we can keep going on. I want you to also do the puzzle penguin. And I'll do a few of these with you as well, and then I'll let you do the rest. Oh, I've got a lot of work on lesson 6 today. This is kind of a tricky lesson. Okay, so number 16. Okay, this one is actually really cool because 3/6. I know that 3 is half a 6, and I know 5 is half a 10. So these two are actually equivalent to a half. All right. 10/12 or 7/8? Okay, 8, 4, 8, 12. I'm going to use rule number 2 for this one. So 10/12 versus 7/8. Now I'm going to say, okay, 12, 24, 36. Those are my multiples of 12. 8, 16, 24. Oh, hey, I have a common multiple. That's going to be 24. So I'm going to make 10/12 times a whole equals something with a 24 on the bottom. And I'm going to do the same thing with 7/8 times a whole equals something with a 24 on the bottom. 8 times 1, 2, 3 gives me 24, so that's going to be 3/3. 12 times 2 is 24, so that's going to be 2 halves. 10 times 2 is 20. 7 times 3 is 21. So 21 24ths is bigger than 20 over 24. So 21 24ths, which is equivalent to 7/8, is larger. So I'm going to do that. I'm going to draw that right now. So that's an example of the second rule over here. Multiply denominators. Oh no, sorry, the third one. That is an example of the third one. Find a common multiple. Okay. All right, I'm gonna do one more with you, and then I'm gonna see if you can do the rest on your own. These are tricky. but I know you can do hard things. So 2/6 or 1/5? Pretty tricky. Should we see if we can find a common, this isn't a factor, this isn't a multiple. Should we multiply both of them, or should we see if we can find a common multiple? Let's see, 6, 12, 18, 24. I think we should just multiply them together. Okay, and that would be 30. So 2/6 times something is gonna give us something over 30. And 1/5 times a fraction of 1 is gonna give us something over 30. So 5 times 6 equals 30, so this is gonna be 6, 6. 6 times 5 equals 30, so this is gonna be 5/5. 2 times 5 is 10. 1 times 6 is 6. So 10/30ths or 6/30ths? I think 10/30ths is definitely bigger. So 10/30ths is the same thing as 2/6. So in this case, 2/6 would be bigger. All right. So all you need to do, all I'm gonna assign you are number 12 through 14 on this page. 15, I want you to do the puzzle penguin. And then 19 through 27. Do not worry about this next page. So I want you to just finish the problems on page 316 and 317 that we did not do together. Good luck.